In this question, we have a survey that asked 100 people if they thought women in the armed forces should be permitted to participate in combat, so should fight or not. The results of the survey are shown in the table. So here is the table that contains everything that you need to know in order to solve the 5 sub-questions. So let's just quickly look at the table. For example, this 32 here means that it's a male who said yes. This 50 here is the total number of females, because it's in the same row as females. Okay? And so on. I just want you to make sure that you understand where each number is. The last column and the last row are just the totals. Okay, so we have 50 males, for example, and 50 females. This is something to know. And how many people said yes? 40 people said yes, and 60 people said no. So let's go and answer the questions now one by one. The first question is, find the probability that the respondent answered yes, given that, so this is very important, that it's conditional probability, given that the respondent was a female. So this we write it as the probability of answering yes, let's write it as Y, meaning answering yes, given that it's a female. When you have a conditional probability like this, you always look at the given. The given is that it's a female. So this is the row of females. So you look at only, you pay attention to this. We have 50 females and 8 of them said yes. So this probability will be 8 said yes out of 50 females. And this would be, if you calculate it, will be 0.16 or 16%. Okay? Keep on answering the other questions and then you'll understand things better. So for the second question, we need to find the probability that the respondent was a male, given that, so again, conditional probability, the respondent answered no. So we write this as probability of male, the respondent was a male, given that the respondent answered no. So let's use N to mean the respondent said no. Again, because this is conditional probability, we look at where is the no row or column. It's this one here. Those are all the people that said no. Okay? And then you look at how many people said no. You see that 60 people said no. How many of them were male? 18 out of them were male. So you would say here, I have 18 males that said no. 18 out of the 60 people who said no. And 18 out of 60 is 30%, which is 0.3. Or you can write it as 30%. Okay, let's go to the next one. The next one is, find the probability that the respondent answered yes. There is nothing given here, so it's not a conditional probability. It's just the probability that the respondent said yes. So in this case, you are looking at the total number of people. So how many said yes? We have 40 people that said yes. And what's the total number of people that participated in this survey? It's 100 people, males and females. So in this case, we will say 40 out of 100 people. And this would be 40%, which is 0.4. You can write it like this, or you can write it as 40%. I will just add one question. What's the probability that the respondent said no? The probability that they said no is, you look again, how many people said no? 60. and the total 100. So this will be 60 over 100. Let me do one more. What's the probability that the respondent is a female? No, without condition or given anything. You just ask, how many females do I have? 50. Out of how many total people? 100. So you'd say this is 50 over 100. Okay, so these, of course, are not included in the question. The question, we already solved it. The answer to it was this 40%. Let's go to number 5, page number 5, so which is D. Find the probability that the respondent was a female or answered yes. This is nice because it's an or probability. This or is the union. If you remember, this is the symbol for or. So you write the probability of female or answered yes. You remember, this probability of or is the sum of the probabilities. So it's a probability of female plus probability of answering yes. And if there is an intersection, you subtract it. So minus the probability of female and answering yes. Now, we know that there are females that answered yes because you can see it here. Those are the females that said yes. So this means that this here has a probability. So we need to include it. In other words, these two events, the female and answered yes, these two are not mutually exclusive. They are not mutually exclusive because they have an intersection. There are females that that also said yes. So female and yes is there. Probability of female, remember, you look at the total number of females, 50, over the total number of people, 100, plus probability of saying yes. We have 40 people that said yes out of 100. So this plus 40 out of 100 minus female and said yes is 8 out of the 100. So minus 8 out of the 100. Here there is nothing given, so you always take the total number of people because it's not a conditional probability. And so if you do this addition, it will be 90 minus 8, which is 82 over 100, and that is 0.82, or if you want to write it as a percentage, it's 82%. Now we go to the last question here. It asks, are the events, the respondent is a man, which we called it M. We abbreviated all of this just as M. And the answer of the respondent is yes. Instead of all of this, we called this event the Y event, meaning yes. Are these independent? How do you check if two events are independent? So, if events are independent, then the probability of the two events happening together, so M intersection Y or M and Y, the probability of M and Y, let's see it first. Probability of male and saying yes. So if you look back, you will see that the males that said yes are 32, and that's out of 100 people. It's not a conditional probability, so we divide by the total number. So this will be 32 over 100, which is 0.32 or 32%. Compare this to the probability. What is the probability of M, male only? The probability of male, we saw it before. It's 50 over 100, which is 0.5. And what is the probability of yes, saying yes? How many people in total said yes? You can see it here. It's 40 people that said yes, so it's 40 out of 100. Now, if the events are independent, then the probability of M and Y will be equal to the probability of M times the probability of Y. So we're asking the question, are they the same? If they are the same, then they are independent. But we can see here that the first one, this one is 0.32. We computed it. Now, is this the same as probability of male, which is 0.5, times probability of saying yes, which is 0.4? Remember, this 40% is 0.4. Now, if you multiply 0.5 and 0.4, you'll get 0.2. And you clearly see that this and this are not equal. They are not the same. So this means, I will put it here in a small box, that probability of male and saying yes is not the same as the probability of male times probability of saying yes. And this is exactly saying that the events are not independent. So it means that they are dependent. Okay, there is another way to do it. So go on the next page to see how I would do it in a different way to check that they are not independent. Or if you say not independent, it's the same as saying dependent. Okay, again, we are going to solve this question using a different method. So remember that respondent is a male, we call it M, and answer of the respondent is yes, we call it Y, the event. So are they independent? You can check it this way. What is the probability of saying yes? The probability of saying yes is 40 people out of 100. So you can say here, this is 40 out of 100, which is 0.4 or 40%. Now, what is the probability of saying yes given that it's a male? Now, given that it's a male means that you are looking at this row. How many in this row of the males said yes? It is 32 out of 50, which is 0.64, because it's out of 50, so 0.64. Notice that these two numbers are not the same. And because they are not the same, it means that the fact that male is given affected the probability of saying yes. It changed it. Probability of saying yes alone was 0.4. But then, if you are given that it's a male, then the probability became different from 0.4, and this will tell you that, therefore, saying yes and being male are not independent. So they are dependent events, because they change each other's probabilities if they're assumed. Or what you can do is the opposite. You can say, what is the probability of male? The probability of male is, you can see, it's 50 males out of 100 people, which is 0.5. What is the probability of male given that the answer was yes? This is equal to, so now you look at answer yes. How many males do we have? 32. Out of how many people said yes? 40. And so this is equal to 0.8 or 80%. And again, you see that these two are not the same. And so the fact that yes, the person answered yes, affected the probability of male. The probability of male originally was 0.5. But then when we assumed that the answer was yes, the probability became higher, 0.8. So the same thing here, you can say therefore the event male and the event of answering yes are not independent. So here I chose to write not independent to tell you that it's the same as saying dependent. You can use either not independent or you can say dependent. So in this case, those two events are dependent, or we can say are not independent. And this answers the question.